In this question, we're given an LTI system and we're told that a unit impulse is applied at the input. So the input is a unit impulse. So we expect the output to be the impulse response. And we're told that the output is a sine wave. We're told the amplitude and the frequency of the sine wave. So our output here, this is our sine wave of amplitude 3. So y of t is 3 sine 8t. So because we know that the input is an impulse function, we know that the output is also the impulse response. So by definition, when the input is a unit impulse, the output is called the impulse response. So the question is asking for the transfer function h of s. So to find the transfer function, we would need to find the Laplace transform of h of t. So what we're looking for is the Laplace transform of h of t. So we can simply replace that with what we're given in the question, which is the sine function. So it's the Laplace transform of 3 sine 8t. So this 8 radians per second, that's omega. So using the Laplace transform table, we know that sine omega t corresponds to omega over s squared plus omega squared. So with omega equals 8, the expression for h of s will be 8 over s squared plus 8 squared multiplied by 3. So that's my 3 there. So the final expression for h of s will be 24 over s squared plus 64. So this is my final answer for the Laplace transform. If the question happened to ask for, say, h of 0 or h of 1.5, all we need to do is substitute the values for omega, or for s, sorry, here, with 0 or 1.5. So this is the expression that we found for h of s, and if we need to find a specific value for a particular value of s, we simply replace s in the expression for h of s.